A neutral electroscope can also be charged by induction, which hopefully you'll recall means that nothing is touching and you also have a ground wire. So if we bring a bar with a negative net charge near the electroscope, the electrons in the electroscope will move down to the leaves. So the leaves, each leaf will have a negative charge. It will repel. They'll spread out. If you remove the bar, the electrons have no reason to stay down at the leaves. They'll spread back up to the top and the leaves will collapse back to their original positions. This induction is temporary and there is no charge transferred from the rod to the leaves or from anywhere to the leaves. Again, similar thing would happen with a positive net charge. However, if we want to make a permanent change, we need one more piece. Hopefully by now you know what that is. Think about it and then go to the next slide. The missing piece is a ground. A neutral electroscope is connected to the ground, and now we bring the negatively charged bar nearby. Here's our negatively charged rod. It's nearby, so any electrons in here are going to see the ground and want to go home. So they're going to be pushed by this negative rod. It's going to push the negative electrons out. They'll go down to the ground, and then the scope will have a net positive charge. However, again, note that the charge on the rod does not change because this is induction. None of the charges can leave here. You've got this air insulation. We now have a positively charged electroscope, and these leaves will repel each other. If we used a positively charged rod and brought it nearby, in this case, this would attract electrons from the ground, which would go to the electroscope. They would spread out as far as they can. Down here, I will now have a net negative charge. The leaves will repel each other. Again, the charge on this rod does not change, and the source of charge through the electroscope is the ground. What would happen if we pulled this rod away before we cut the ground? Well, the electrons would just go right back. So the key to leaving a charge, just like when we had the sphere and the charged rod, is to disconnect the ground first and then pull the rod away. If the charging bar is removed while the ground is still attached, the electrons will return either to the ground or to the leaves depending on the sign of the charging bar, until they have a neutral charge, and the leaves will then fall back together. In order to leave the charge on the electroscope and keep the leaves separated, the ground must be removed first before the charging bar. The electrons will now have no place to go, and a net positive or negative charge, again depending on what sign the charging bar was, will be left on the electroscope.